Hello students, welcome back to the new module of our chapter called Magnetism. Students, in this particular module, we'll be learning two important terms called as magnetic susceptibility, Xi-M, and second one is magnetic induction due to magnetization, given by symbol Pm. Right? Now let us start with our module with the very first term called as magnetic susceptibility, given by symbol Xi-M. Now students, in the previous two modules, we have already learned what is magnetic intensity and what is magnetization. What is magnetic intensity? It was the ability of the field to magnetize the magnetic material. And what was magnetization? Magnetization was the ability of the magnetic material to get magnetized. And the relation between these two quantities can be established by this particular term called as magnetic susceptibility, right? So let us define this term called as magnetic susceptibility. It is defined as the ratio of magnetization produced in the material, which is Mz, to the magnetic intensity H of the magnetizing field. So it is nothing but the ratio of magnetization which is getting produced inside the material to the magnetic intensity H of the applied field. So if I write it mathematically, I can say magnetic susceptibility Xi-M, it is equal to magnetization Mz upon magnetic intensity H. Now make sure you remember that magnetization is produced inside the magnetic material, right? And this magnetic intensity H is the external magnetic field, right? Clear? So if I write it further, what will I get? I'll get Xi-M is equal to Mz upon capital H. And if I transfer this capital H on the left hand side, what will I get? I'll get Mz is equal to Xi-M into capital H. Now this relation is a very important relation between the magnetization produced in the material and the external magnetizing field, right? Clear? Now students, this relation will be using in the forthcoming derivation. Now students, one more thing. Now magnetization was having a unit ampere per meter. At the same time, magnetic intensity also has unit ampere per meter. So both terms Mz and H both have same unit. So what will be unit for Xi-M? Unit for Xi-M will be nothing. Or I can say Xi-M will be unitless, and as along with that it will be dimensionless. So I can say magnetic susceptibility is unitless and dimensionless, right? Now let us move towards the next term called as magnetic induction due to magnetization, given by symbol Pm. Now whenever we keep a magnetic material, let's say this is our magnetic material. Now whenever we keep a magnetic material inside a current carrying solenoid, so let's say this is a current carrying solenoid, we know that a current carrying solenoid will produce some magnetizing field, and due to the magnetizing field of the solenoid, this particular magnetic material, this material will get magnetized, right? So I can say material will get magnetized, and it is measured in terms of magnetization Mz. Now students, due to this magnetization, this magnetic material which is present here over here, this will start behaving as a magnet, and it will have some additional magnetic induction due to magnetization, which is given by symbol Pm. And this magnetic induction is produced inside the material, right? So here we are having two fields. First one was the field which was produced by the solenoid, right? And second one is the field which is produced due to the magnetization of this particular material, right? Now let us move further. Now this magnetic induction which is produced inside the material is directly proportional to the magnetization. So greater the magnetization, greater will be the magnetic induction Bm, right? So I can write it as Bm directly proportional to Mz. Now removing this proportionality sign with the constant, what will I get? Bm is equal to mu naught into Mz, where mu naught is the constant of proportionality, and it is referred as permeability of free space or vacuum. Now let us move further. Now what can you say about the total magnetic field or total magnetic induction for a solenoid? So I can say total magnetic induction B is equal to magnetic induction B naught. Now this magnetic induction B naught is produced because of the current carrying solenoid, plus the magnetic induction due to magnetization. This is produced inside the material. So I can write total magnetic induction B, it is equal to B naught plus Bm, where B naught is the magnetic induction of the current carrying solenoid and Bm is the magnetic induction which is produced inside the material of that particular solenoid. Right? So students, this relation is very important. We'll be using this particular relation in the forthcoming modules. Till then, keep learning. Thank you.